Hello and welcome. So in this video I will go over pretty much every node of Godot 3. So to give back some context to this, as some of you may know, I give classes at Computer Science Association of the University of Bordeaux in France for fun, to help people where I go and show them some of the ropes and how game development happens along all the main domains I could think of. So this is the second year I'm giving this class, and with some changes in the program and the fact that we have missed 2 weeks because of outside events, I've taken one of the classes I had, the third programming class, which was on the tools in the engine in general, and moved it as an advanced subject, or more like a bonus this time. And since I just done with recording it in French, I figured it's not too much of an effort to also make an English version that might be accessible to more people. So in the end, I'm thinking maybe making all of those classes into better quality videos, not just a single take recording like this one. But hey, that might give you a first taste of it. Anyway, so the slides are in French, but don't worry, the text is mostly a repeat of what I'm saying, so that people can follow along and follow when I'm not talking with them. But yeah, otherwise, I hope my accent doesn't weird you out too much. Yeah, let's see a bit what this is all about. So at this time in the class last time I went over the video game making and the people working on that, and so I wanted to, because we're going to use game engines, and game engines have a lot of tools, it can be pretty intimidating to start out. So I wanted to make a little class on the tools available. And since Godot is very based on nodes, I went ahead, read all the nodes in the documentation, which are about 200 of them, a bit less, and classified them, and will explain like those categories in general detail. So that's a quick pass, about 30 minutes, probably, which will just give you an idea of what is possible. So if something interests you, it will be you should read its documentation before using it, to see all the actual tools it has to offer. So this is, by the way, at the time of recording, Godot 4 is on the way very soon. This one was made, so this class was last year with Godot 3. So from what I understand, a lot of it still applies, but that's something you want to keep in. You might want to keep in mind. So to give more context, in Godot, everything is going to be nodes, as opposed to some other game engines, which we are going to use a concept of scenes, which are going to be a whole level, and prefabs, and game objects. In Godot, everything is going to be a node, and those nodes are arranged in what we call a tree, which is a computer science structure, where you have one root node, and each node can have several children, so which can then have their own children, etc. So, and here that's what we have, and each node has its own functions and uses. So to give an example of what a structure level in Godot would look like, you would have your main root, which is given by the engine, and which will then have several children, which can be the level or a character. And a character itself, for instance, is going to be defined as a kinematic body for its root node, which will handle its physics. And as children, it will have a collision shape, to like a capsule, to know where it is on the physics engine. A mesh instance, so you can render its 3D model, and one animation player to have the model actually move if it's a character. So not all nodes are important, so I put advanced, avancé, above on the slide's name where the nodes are more niche, you know. So another concept that's pretty important with Godot is nodes is the concept of scripts. So in addition to his base functionality, every node can have a script which is written in GDL for Godot Development Language. So the easiest way to see it is that the script is the one handling the logic, whereas the node is the actor, like the body. If the script is the brain, the node will be the body. So if I have an arm, the arm has all the muscles and stuff to move, but the one giving order is the brain, so the scripts here. So by combining the two, you can make complex behavior and entities really quickly. And because all the complicated parts that are in command are hidden by the engine and written in a faster language, which by the way you can extend, but that's another subject. So there's a few base nodes before we head into the main ones. So the base of nodes is node. So that's the common part. It contains all the basic functions that all nodes have access to. From there you have three main types, which are control, node 2D, and spatial. So control is going to be everything that is on the user interface. So for instance, your health bars, the menus, stuff like that. And while node 2D and spatial are going to be representing the world itself. So node 2D is for 2D worlds and spatial is for 3D worlds. So in addition to that, you might want to know that control and node 2D have a common part too, which is canvas item, which handles drawing on the screen. And some other nodes don't inherit from those three main types, and those nodes are not part of those three main groups, and include nodes like the sound nodes. And for most of the nodes we are going to see, there is a variation in 2D and 3D, which function pretty much the same way. So what are the main categories I've chosen? I've handled it along 5 categories. The first one is physics, which is everything that is along the side of movement and collisions. There's gameplay, which are small tools, small additional tools to help you create the game, for instance, to create the levels with tile maps. There's the graphics part, which is going to talk about the 3D rendering and 2D rendering nodes. And then there's everything that is UI, so menus and stuff like that. And then the ones I wouldn't put anywhere else, which are small additional subjects like audio and VR. So let's get started with the first one, which is physics. So there's 2 types of physics node, so of main types, which are going to be the ones finishing with body, which are going to define an entity and its main behavior. And then you have a collision shape or polygon, which give the actual shape, the actual collider, which is going to be used. So for instance, if one is going to be a sphere to represent like a ball, or if something is going to be a capsule for characters. So you have 4 main entity types. So you have the static body, which are for elements that don't move, like the terrain, for instance, or fixed platforms. There's kinematic bodies, which are entities which move with precise movement, like you say exactly how much you want to move with it. So this is going to be characters, for instance, especially in platformers. Then you have rigid bodies. So this one is directed exclusively by the physics engine. So for instance, so you can make balls that fall down and stuff like that. The difference with it is that instead of giving precise movement and having precise collision management like in kinematic body, here you just give forces and let the physics do the rest. And finally you have area, which doesn't have body because it doesn't have any collision, but it detects collisions. So for instance, it can be a hole, like in you have a pit in a platformer, or this can be like a trigger to spawn enemies or a cutscene when you walk into it. In addition to that, so you have some a bit more specialized in physical behavior. You have vehicle body and vehicle wheel for in general vehicles with wheels with wheels that touch the ground, which is only available for 3D. keep in mind, by the way, that you may not want to use a vehicle body for your game, depending on what exactly you want to achieve with it. It's just an additional tool for physics-driven vehicle games. If you want to do ragdolls, you have physical bone or physical bone 2D. Ragdoll is when the character doesn't have any, just is driven. Now a character armature is driven by the physics engine, like in FPS is when you shoot someone and he just flies off and while dead. And then you have also joints, which you can use to help constrain movement. So there are a lot of types, like hinge joint, pin joint, and they are different between 2D and 3D, so take care about that. Then you have the gameplay nodes, so those are mostly helpers. So one of the first ones you're gonna see is the tile map and grid map. So a lot of games, especially old ones, used a grid system to create the levels. Like if you think of Mario Maker, for instance, that's exactly what you're doing there. So these small grid elements are called tiles, and you can create your own tiles in Godot first of all, and then you have tile map and grid map, which help you place them on the map. So they have both a graphical interface where you can just click to place your tiles, and a programmatic interface to help you place them dynamically, like if you do a procedurally generated game. Then you have navigation, which is a whole subject. So because sometimes you want your entities to move to a specific part of the level in a more complex manner, more dynamic manner, like in RTSs. So this is handled by a family of algorithms called pathfinding. So this is a fascinating subject in general, which we will not dive deep into it here. But if you want to learn more about it, you can search for pathfinding and some algorithms like Dijkstra's algorithm, which is the classic, and A star, which is going to be the one that is the most used. But most of the time, so you have to define your space like a grid or etc. But a common solution that is handled in a lot of game engines is the navigation mesh, or nav mesh for short, which is a mesh, a 2D or 3D mesh that represents the walkable space of your game, and you can then use that for actors to navigate it with navigation or navigation 2D. And if you need some simpler paths, you have the path and path 2D nodes, which can be combined with the path follow and path follow 2D nodes, which can help you define a path, which can be very useful for rail shooters, bullet hells, stuff like that. Then you have a few helpers, additional helpers, like the visibility notifier, which tells you if a node is visible on screen or not. Proximity group, which helps you detect nearby objects, and the spring arm, which can be used to soften the movement of various objects, like as if you attach the spring in between the two of them. So that's one very useful case. It's for a camera that orbits around an object. So that way, when the character moves away from the camera, the spring will bring it back towards the rest position, and oppositely, if he moves towards the camera, the spring will push back the camera, which helps make the movement slower and thus not give motion sickness to the players. Now let's talk about one of the big parts, the graphics. So let's start. We're going to be mostly talking about 3D graphics because it's more complex, but a lot of the concepts apply to both. So as we will see, so to show one, you will use the mesh instance node, which can also be used as multi-mesh instance if you have to display the same mesh several times in a faster way. So that will just show your mesh with the materials and stuff like that you apply, and this is and you can deform it with the skeleton nodes, which we will see, maybe not in the video, but you see that to create, when you have a character and the usual way to move them is to create an armature inside of them, which is composed of bones, and these bones are associated to a part of the model. So to give a concrete example, if I want to move a character's arm, I will start by making two bones for the arm. So one going from my shoulder to my elbow, the second one from my elbow to my wrist, and then I can just move these bones instead, and it will move my whole arm, like if I was moving a doll or an action figure. You have on top of that, you have skeleton IK, which helps you direct some parts of the body, which is mostly used, for instance, to place feet on the ground. Like if you're in stairs, instead of having the character stand on invisible ground, you can adjust the position of the feet to make him stay on the stairs. So, by the way, if you're importing from a software like Blender, you will probably already have the mesh instance and skeleton placed for you, as well as an animation player. We'll see that a bit later. You have soft body, which is to make meshes that represent clothes, which aren't rigid bodies. So you can have a cape or like a white dress or a flag, stuff like that can be handled with soft body. And if you want to make geometry quickly from the editor or the code, you can use immediate geometry or CSG for constructive solid geometry. For light, then you have the big part of rendering, which is light. So that's so since rendering is mostly computing where light goes, so that's a big subject. We won't delve too deep into it right now. But so you start by having some basic light types. So you have the directional light, which represent one light that has always the same direction. For instance, the sun. You have the omni light, which can also be called point light, which represents just a point, which is like all the light bulbs you see in general. And you have spotlight, which instead of sending light everywhere, it's only sent in a cone of light. So from that you are going to have all the local lighting, so to local illumination. So to give a bit more context to that, you can separate rendering into two parts for light, which is local illumination and global illumination. So local illumination is just when the light goes from the light to an object and then to your eye, and is going to be the main source of the color. So you have and it's really fast to compute. It's really easy, but in practice, that light that bounces from the object can bounce to another object and then another, and then finally to your eye, which will change that appearance. And this is a big part of making scenes feel connected. But it's also really expensive, and a lot of effort has been made on that end. So, and Godot has a few nodes to help you with that. So you have the baked light map, which is basically, instead of computing all those expensive computations at runtime, you instead do it before the game starts for the static elements only. That way, instead of computing like the shadow of the building on the ground, well, it will already have been you just draw it into the texture automatically, which means that, well, you're gonna have all your light already there, all your complex light effects already handled there, and basically free at runtime. But if you need some other solution, like if you have elements that move or dynamic time of day, you can use GI probe and reflection probe, which are two systems. For one for the diffuse part, which is the classic one, the less for the effects that have less precision, and the reflection probe, which are for the reflection effects and the really shiny metal objects, for instance. So they work a bit differently. GI probe just handles a few coefficients to remember what the light around it approximately looks like, to help you give some color. And reflection probe will actually do a full render of the scene around it to reference when you have a pixel that needs reflection information. So that's pretty slow, but this interface allows you to make abstraction of it and let Godot handle those computations. And finally, you have the world environment, which will handle stuff like ambient lighting, which is an approximation so that even if you don't have indirect lighting implemented, you can still see the light, that some basic light that would have been there because of the bounces, but you don't compute it. So that's a complex subject. We will talk about, in the class we'll talk about it in the specific class on shaders. But don't hesitate to ask questions in the comments or on Discord, because that's pretty much my main domain of expertise. But for 2D parts, you can use Light 2D and Light Occluder 2D to hide what you can see, because by default you won't have light in 2D. Usually just draw the sprites. So for rendering, then you need a camera. You need the point of view. So the camera in 3D has a lot of parameters like field of view, etc. But you also have some additional cameras that automate some components. For instance, the interpolated camera will do like the spring arm we talked about earlier. Will smooth the camera's movement to not give motion sickness. And then you have the viewport. So that's now when you don't want to do the rendering directly on the full screen. You can instead render to a viewport, so which can either handle output it to a specific part of the screen, which can be very useful for split screen games, like Mario Kart, for instance, where every player has his own camera, which is rendered to a viewport, which takes a quarter of the screen. Or you can do that to make rendering in textures to make more advanced effects, like if you have a camera and want to display it on a big screen, for instance, like in a stadium or something, or for very specific graphics effect, like to handle someone walking in the water and or in the snow and remembering where he went. But you can also use it for some more gameplay systems by combining it with geometry layers, render layers, sorry. For instance, to display a minimap by only displaying the minimap relevant meshes and putting the camera above the player, and rendering that to a texture that you will then display as a texture on the UI. Then you have all the animation parts. So Godot's animation player is a bit special because it can animate pretty much every property. So that's very powerful, but it's also a bit unwieldy for most parts, because that's often not how we think about the way we can animate in games. So, and sometimes there are more efficient solutions. So that's a capacity to keep in mind. That is very useful for like menus, animation. But most of the time you're gonna use the animation player like a classic animation player to play the animations you have exported from Blender. So, but in addition to that, you have the animation tree player, which gives you a bit of control, a more advanced control on the animations, like which animation can play after which one, and their order and how they mix with each other. So to give a simple example, like if you have animation of the character running forwards and running on the side, you can mix them both to create a character running in diagonal, or mix two animations, like one animation for the arms as the character is holding his rifle, and one for the legs as he is running backwards, for instance. Root motion view is a helper to help you create or visualize some animations where the animator will also move the whole character. Like if you are making a walking animation and you move the whole character, you can visualize that and maybe correct it. Then you have there's another more advanced subject, which is occlusion culling, which is an optimization method that whose basic concept is, since there are objects you don't see on the screen because they're hidden by another, there's no need to send them to the graphics card, which is going to be faster. But that's a really complex subject to know what is going to be drawn in front of something else without drawing it. So there's a whole family of methods which are called occlusion culling, and Godot provides some of them with the occluder node, which helps you create parts that will count as occluding others. And then there's also, but it also offers support for an older system, which is very manual, which for interiors, which is the rooms and portals, where the idea is that you separate your area in rooms, which contain several objects, and you can see these rooms only if you are inside the room, or if you can see it through a portal, which can be a door, a window, etc. So so you have to place them manually, but if you know you're not going to be able to see the room, you don't even send it to the graphics card, and it's pretty easy. But yeah, Godot has some nodes to handle that. And for the 2D parts of rendering, you have sprite and animated sprite, which help you show simple images. But if you need some geometry instead, you have line 2D and polygon 2D. You have the canvas layer, which is basically you group your nodes together, usually by as a layer. So you have, for instance, in a platformer game, you can have your hero in the fields, and you have the character and the actual geometry he's going to walk on as part of the first layer, and a castle in the distance, the mountains and stuff like that, as a second layer, which helps you put some effects directly. Like with the canvas modulate, you can create atmospheric effects depending on the time of day, for instance. But one of the most useful application is going to be parallaxing, which is also available through parallax layer or parallax background, which allow you to move the whole layer together at a different spin than the main layer. So for instance, if your character walks to the right 100 units, maybe the background will only move 20. This simulates pretty accurately the perspective, and thus gives a sense of depth even though you're using only 2D layers, which is why it's a very useful method. And you have also camera 2D, so it has a lot less parameters than the 3D one, but it helps you limit the area the player can see pretty easily. And you have a back buffer copy, which is an advanced node used for some screen reading effects when you do shaders. And finally, there's a bit of additional stuff. So you have the particles, which are used for VFXs, so visual effects, which are going to be usually either some bigger, softer effects like which are non-solid effects like fog or fire, or more unrealistic effects like heat sparks, lines of movement, stuff like that. So there's variations on that node for 2D particles, and to compute them on the CPU too. And you can also sometimes use some of the concepts of 2D in 3D and vice versa, with sprites in 3D using Sprite 3D or Animated Sprite 3D, which will display them like a billboard. And on the opposite hand, you can use Mesh Instance 2D or Multi-Mesh Instance 2D to use 3D models in the 2D world. Now let's get to UI. So UI is a big part of Godot, as the Godot editor is itself made with Godot, and that can be, which means the UI is very flexible, even to go further, to create tools, which is something I think is very important in game development. So to give a bit of context, the control nodes, as opposed to the node 2D nodes, are very referenced compared to the screen. Like the node 2D assume you are in a world, and thus your position represents the position in the world, which is then going to be displayed on screen depending on where your camera is, whereas the UI is displayed compared to your screen itself, which is why you have anchors and stuff like that, which allow you to specify, yeah, I want my panel to be wide as the screen and tall as 20% of the screen, and display at the middle. So yeah, so with that out of the way, let's look at some of the basic nodes just to show stuff on screen. So we have color rect or texture rect, which just shows a simple color or a simple image. So for instance, you can put the character's head, for instance, or the lives icon, something like that. And then you have label or rich text label, which allows you to show text. So for instance, a player name, a dialogue, or for instance, the number of lives still remaining. panel allows you to make to put a background behind a group. So you have something similar called 9-patch-rect, which works better when you to show a specific texture, like if you want to have a dialogue bubble. But the problem with just using texture rect for that is that it's going to be very stretched. Whereas with 9-patch-rect, it will cut your texture in 9 parts and will keep the corners untouched, will stretch the borders on their main axis, and will stretch the center to cover everything, which allows you to not have the texture deformed depending on the ratio or size. And then you have progress bar or texture progress, which allows you to make various progression bars first of all, but it can also be used to make health bars. And it has support for, as far as I remember, it also has support for not only the straight ones, but also the circular ones, for instance. So that's pretty useful. But then when you have to take input from a player, you have a few options. So you have the classic button or texture button, which shows a button, and which can then handle the input of, and has some options like being toggleable. You have line edit to just write a bit of text. For instance, you ask a player for his player name. And then you have touchscreen buttons. So it's technically a Node 2D instead of a control, but I think it's but I've put it here. And this one represents buttons for when you do games on mobile touchscreens. It can be you don't have access to like a keyboard or a controller most of the time. So you're gonna want usually to display fake buttons on the screen or a fake stick, and this is what helps you with that. Then if you want to position your nodes correctly, that we're going into more advanced territory there, but you have containers which can position stuff automatically and dynamically. So the classic ones are center container, aspect ratio container, margin container, and panel container, which help you position a single node pretty easily. Like center container will center it, aspect ratio will keep the ratio of the node you want, margin will push it a bit, and panel will add a background behind it. Then when you have several nodes, you can use hbox container, hsplit container, or grid container, and the vertical variations, which allow you to put elements one after the other. So for instance, an hbox container will just put the elements one next to the other, and has some controls, of course, to handle the position better. But those are very useful nodes. And as a bit of a bonus, you have H separator and V separator, which are basically just horizontal or vertical lines to keep a bit of room and help you separate some buttons. But sometimes you want to make menus or applications, or even for some games. For some games like 4x's and tools in general, you can use windows and pop-ups, which there are a lot of with window dialog and the pop-up series of nodes. So there's a few pre-made ones, and there's generic ones you can make yourself. If you have a lot of options to show, you can use a tabbed container, so tab container with tabs, or a scroll container to help make big menus. And you have some more specialized buttons like menu button, option button, tool button, link button, which have already some of the functionality implied, like option button will allow you to select one of several options, or the menu button will open a small menu for you. And you have item list, which is just a list you can select in. From that, you have some of the more advanced inputs, so checkboxes, for instance, with check button or checkbox, which can make checkboxes. Spin box allows you to put numbers, which you can also do with H slider or V slider, which have more strict limits. And you have text edit if you want to write more text than line edit. Line edit is just like I want you to enter your name. Text edit is like enter your biography, so your life story. But it has a lot of functionality. So you can even make even use syntactic coloration. I think that's the word. Or put breakpoints, stuff like that. And then you have some specialized, very specialized inputs like the color picker or the file dialog. If you want to make nodal editors, you have a graph node, tree, and graph edit, which can help you make that. Video player is a node to show videos. And viewport container is an interface to help you display viewports more easily. So as we said with Mario Kart earlier. And finally, there's the miscellaneous nodes, which are those that didn't fit in the previous categories very cleanly. So one of the first one is the sound nodes. So with you have spatialized and non-spatialized. So the difference is that a non-spatialized sound is going to play the same regardless of your position, while a spatialized sound will take your position and the sound's origin into account to modulate the volume, add effects, stuff like that. So audio stream player is the one if you don't want any specialization, so for instance to play the background music. And while you have audio stream player 2D and 3D, which can be combined with the listener and listener 2D to create the sound. So Godot has a lot more functions, it's not just that, he has the audio buses for instance. However, something that's interesting here is that Godot 4 system is more complex, more complete. So if you are interested, I would recommend you to look to Godot 4 instead, to check what new features are coming into. And VR and AR nodes, so virtual reality and augmented reality. So you have some function in Godot. So at the time I wrote this about a year ago, it was a bit bare bones. You have the AR VR camera, anchor, controller, and origin nodes. But from what I've heard, Godot 4 once again also improved a lot on this part. So you might also want to check the newer version if you want to make a VR game, for instance. And finally, there's a few utilities. So for instance, the HTTP request that will allow you to make, HTTP requests more easily. Resource preloader to load resources from the disk in advance. Timer, which will help you handle like events that are delayed. A twin, which helps you animate stuff simply, which is very useful for menus once again. Which are pretty common functions, but offer another interface. Then you have position 2D, position 3D, and reference rect for Node 2D, spatial, and controls respectively, which are helpers, which are only visible in the editor to allow you to see where an object is. For instance, a monster spawner, which by default won't have a monster and doesn't have any display, but with that you can still see it in your level editor. Then you have remote transform 2D, which help you move objects which are in another part of the node tree easily. And Y-sort, which sorts the node depending on their Y position, which is very useful for 2D games which have a top-down perspective to handle the drawing order. And finally, Raycast and Raycast 2D, which give you a visual helper for a simple raycast, physics raycast, by the way, not the rendering kind of raycast, which you can also do in code, but this one allows you to visualize it easily. For instance, if you have a gun and you want to treat the bullet as a ray, you can just put the raycast node at the barrel to have it shoot from the correct position. So that's it. Thanks for listening. I'm going. There's a small appendix with all the node names. So those are the internal names. I just translate the categories, which is and most of them are stuff we already seen in this class. So for the base nodes, the base nodes we talk about. For physics, we have base nodes, the advanced nodes, and the specific joint nodes. Which, as you can see, there are pretty different ones for. For 2D and 3D. There's the gameplay, so level creation with grid map, time map, navigation with all the navigation meshes and the paths, and the helpers in general, like spring arm. For graphics, we have light and environment, which we talked at length about, geometry, and general rendering, so cameras and viewports, and animation. Which then you have the 2D parts, the specific 2D, and the occlusion nodes, and finally the other ones, the particles, and the 2D in 3D and 3D in 2D. Then for UI same stuff. It's the same as a slide, of course. So display, simple inputs, positioning. For the more specialized stuff for menus and application. The more that is closer to forms, so more advanced inputs, and specialized nodes like the graph edit, the nodal editors, and the specialized dialogues, stuff like that. You can see reference rec too here, and then the other nodes. So as we said, for audio and then VR, AR, you might want to see Godot 4, and the utility node. And so that's it. So here, I mean, that's where I tell to my student next time it's gameplay programming. But I don't know if you guys are interested in me making more videos. Maybe in the future with a bit more interaction instead of just me going through the slides in French. I recommend to on the site to test out the engine a bit, to read the documentation of the nodes that interest you. And if you have questions, don't hesitate to ask them on Discord or on this comment section. Well, hope you enjoyed this this reading of French slides. And have a very nice day. Bye.